This is a question on differential equation. You can take a minute to read the question. So the resistance R of a newly manufactured conductor is known to increase with the temperature theta. So engineer A proposes that the differential equation, the second derivative, yes, to model the relationship between R and theta, while engineer B believes that relationship is better represented by this. So they are asked us to find general solutions of the two differential equations given above, that means this and this, expressing R in terms of theta for both cases. You may assume that both R and theta are non-negative quantities. So let's look at what engineer A proposes first. So engineer A proposed that this is the second equals to 1 over 10,000 e 0.01 theta. Alright, so to integrate this once, I will have the second derivative becomes the first derivative, and I will have this integrate 10,000 e 0.01 theta. Now we know that, let's say, to integrate e ax dx will give us e ax over a plus c. This is okay, so where a is the constant, so now a is our 0.01. So I have this 10,000 and this one, when I integrate this part, it will be 0.01 theta over 0.01, right? Then plus c, where c is a constant. Okay, so this will give us 1 over 100 e 0.01 theta plus c. Now to integrate once more, I will have r equals to this one. When I integrate this again, I'll have nope, it's on the whole thing, right? So I have integrate, no, so I've done it, I will have done this. So now it would be 1 over 100 e 0.01 theta over 100 over 0.01, the plus c theta plus d, where d is a constant too. So now I have 100 times 0.01 is just 1, so I have e 0.01 theta plus c theta plus d. That's what I have. So this is for engineer A. Then how about for engineer B? For engineer B, dr d theta equals to r second square 2 theta. Now I rearrange, put r on one side, I have 1 over r dr d theta equals to second square 2 theta. Now I could just integrate like this. So the d theta I'll bring over, so I could get integrate second square 2 theta and d theta. So something like this. So when I integrate with respect to r, I get ln r. This is the purpose of bringing r to this side because dr is here. So ln r equals to integrating second square 2 theta, I get tangent 2 theta over 2. So because differentiating this, I'll get second square 2 theta. So this would just cancel, the 2 will cancel out with this 2. So let's say plus this one I will not use d, I will use e. So to prevent, so where c is a constant, where e is a constant, So give a reason why the model proposed by engineer B cannot represent the relationship between R and theta. Now, what is our R? R is the resistance of a newly manufactured conductor and is known to increase with the temperature D. But you know, for tangent 2 theta plus over 2 plus E, so we know the behavior of, okay, so because let's say if tangent 2 theta, okay, let's see why this could be, okay, plus theta plus d. We need to look at maybe we could look at the graph of both to see, because tangent to theta is not always increasing. So let's say r equals to e tangent to theta over 2 plus e. What would happen? Now we know that for some values of theta, the tangent to theta is undefined. Correct. So for example, if when tangent graph looks like this, there are points where it is undefined. For example, at tangent, what is tangent 90 degrees? What is tangent 90 degrees? At tangent 90 degrees, it is undefined. So what if I have a theta at a half pi degree? This would be undefined, and your resistance would be undefined, and then suddenly it would drop to another graph here. So it is unlikely that the resistance will vary with this, because there will be points where the resistance be undefined in this case, right? So that would be the reason. So using the model proposed by engineer A, find the value of theta when r equals to 200, given that r equals to 100 and dr theta equals 0. So now let's see. Okay, let's solve the other question. So let's say if my r equals to 100, my theta is equals to 0, so E0 plus 0 plus D. So that helps me solve for my D. My D is just equals to 99 because this is 1, so D equals to 99. And what about my C? dr d theta equals to 0.1. So 0.1 equals to, so when theta equals to 0, so this one would be 1 over 100. E0 is just 1 plus C. So this is 0.01 plus C, so C equals to 0.09. Okay, so I've gotten these two variable I want to find when r equals to 200. What is the value of my theta? So when r equals to 200, my value of my theta is E 0.01 theta plus 0.09 theta plus 99. So how would I solve such a question? 99, if I shift it over, I will have 101 equals to E 0.01 theta plus 0.09 theta. So when theta, the variable is on the power as well as on the base, I usually use the graphic calculator to solve for such a question. So, but then before that, I would like to simplify it. Let's remove this equation first. So before that, I would like to simplify it by letting y equals to 0.01 theta. Then I will have 101 equals to EY plus, this would be 9 theta. Okay, this would be 9, sorry, 9y. Okay, so how do I solve this? Okay, 101 equals to EY plus 9Y. So I'll go to Y equals. So one side I will put 101. Then on the other side I will put E X plus 9X. I hope I got it right. EX plus 9X equals 101. Okay, so then I would graph it. It wouldn't be, since my intersection point would be at 101, I should set my window such that it is higher up, so probably at this one would be between 100 and maybe I'll let it be 99, and this one would be 105, so to give me a better picture, right? So, and yeah, I'll just let the X minimum and maximum be that for the moment. See where's my other curve. It may not cut in this region, so I may need to, yep, okay, it does cut here. So I will try to calculate the intersection point. First curve, yes. Second curve would be yes, yes. Enter again. The point of intersection will be at 4.1529781. So 4.1529781. So therefore my Y is equals to 4.1529781, which means that my 0.01 theta is equals to 4.1529781. Okay, sorry. And that would mean that my theta is equals to 415.29781. And alright, so that means when the resistance would be 200, when R equals to 200, my theta is equals to 415.29781. Okay, and that's it.